All right, everyone, welcome in. This is going to be another sort of practical reasoning using computer science for students to practice a little bit about logic, reasoning, and a little bit of proof structure. We're going to get into proof structure today to warm us up for writing proofs in the videos to come. So I want to put us into a context here. We're working for Movie Max, which is a theater. They offer student discounts to students, and they have certain criteria that you need to meet if you want to earn the discount. So first of all, you have to be a student, and to do that, you have to come with valid student ID and be currently enrolled. You also can only come at certain times, so you can come for any matinee showing or on the Tuesday discount day. And then also, if the movie is rated R, the customer must be 17 or older or be accompanied by an adult. So these are some criteria that need to be tested. Maybe if you were like me and you worked at a box office when you were a teenager, you would have to check these criteria for people coming in. Show me your student ID, how old are you, et cetera, et cetera. So we're going to imagine now that we have sort of an automated system. Maybe this is working on the online system for purchasing tickets, and it's got some logic involved to check to make sure that the individuals requesting the student discount qualify for the student discount. And of course, you've probably had some experience writing this type of logic. We sometimes call this business logic because it's the kind of logic that shows up in these kind of business tasks. There's, lots of criteria and constraints and such. And then we just need to test to make sure that the criteria are made to pass. So we can imagine here that one of our friends, Alice or Bob, has gone ahead and written some code. Maybe they wrote it together this time, and they've come up with this can get discount method here with a few pieces of data coming in. Let's just make sure it has a student ID. Okay, I think I know what that means. Is enrolled. Okay, yeah. The show hour, so what time the show is on. Is it a Tuesday or not? So it's not even the day of the week. We just have a Boolean that says, is it Tuesday or not? We have a movie rating. That's not how good the movie is. Is it a rated R? Because we need to check to see if you're old enough or you have an accompanying adult. Okay, so that's these are our input variables, and then obviously we're just going to have a little bit of logic here. Let's take a look at some of our logic. So first we compute something called student valid by computing the AND of these two inputs. Then we have a time valid calculation. That is our show hour is less than 16 and it's not a Tuesday, or the show hour is greater. And okay, so we've got a little logic there that we store into this variable. And then it looks like we have a branch here. If the movie is rated R, we calculate if the age is valid, else we have another condition. It looks like just setting it to true if it's not R. And then it looks like we're returning the AND of these three things. Okay, so what are we going to do in this video is what we're trying to do is assess how well these two things match. Sorry, on the left-hand side, these are the requirements or the specs. But over here, we have our code. This is our implementation. This is a very common problem that we face both just in coding and debugging, but also in code reviews, etc. If you're doing a code review of someone else, you're going to have to go through this process where what you're trying to do is see, hey, do the specs match the code? And one way we do this is writing tests, and you may have some experience writing tests. Well, we're going to think about tests here not necessarily as automated, which you should in practice, but from the logical standpoint. So we're going to think, how do we test this code to make sure that it works, and how do we find some errors that there might be? So the first thing we probably can see here is that there's some correlation here between conditions. We have this student condition, we have a time condition, we have a age condition as well. These seem to be lining up on the left-hand side. Luckily, that's already a little bit of a breakdown that allows us to do some comparison. Let's look at our first one. Student valid. The requirements say they must have a valid student ID and be currently enrolled. Has a student ID and is enrolled. So the logical structure on the right and the logical structure on the left seem to match up. Okay, now let's take a look at the show time here. Either it's a matinee showing before 4 p.m. or it's on a Tuesday. So let's look at our logic over here. So we've got a show hour is less than 16. So that's in the afternoon. That's the matinee. And it's not a Tuesday. Or the show hour is greater than or equal to 16. And it is a Tuesday. Okay, now I don't, immediately my brain is a little fuzzy on this logic. And you might be too. I'm looking at this logic and it doesn't seem to match what's on the left. But what happens in logic a lot of times is that there are many ways that you can write down one logical sentence that are equivalent. So it's possible that whoever wrote this code was thinking about it in a different way than I was, and they've written down a correct version here. Or it's possible that they've written down a buggy version here, and we need to catch it. So how are we going to do that? Well, we need to test certain conditions. So I'm going to start out here by looking at exactly my showtime conditions here. We either have to be a matinee or on a Tuesday. So let's think of a couple things. We could be on Monday, and it could be at 2 p.m. That's a Monday matinee. Or we could be at Monday at 7 p.m. That's Monday, not a matinee. Or we could be on Tuesday at 2 p.m. That's a Tuesday matinee. Or we could be on Tuesday at 7 p.m. That's going to be Tuesday, not a matinee. Now these sort of create the 4 possible criteria that we want to consider, because these are, if we think of them, we have matinee or not matinee. So I explicitly want to highlight here our logical connected. Here we have Tuesday. Here we have not Tuesday. I don't need to try the same inputs with Wednesday or Thursday or Friday, because those are also not Tuesday. We only have 2 cases here, Tuesday and not Tuesday. We only have 2 cases for the matinee as well. Matinees are not matinees. So now what I want to do is I want to look at these 4 boxes, and I want to think, when are the ones that the students can get the awards according to our logic up here? Must be either a matinee showing or on Tuesday. That means if we're in the matinee row here, we get the discount. Or if we're in the Tuesday column, we get the discount. The only time we don't get the discount according to this is if it's not Tuesday and it's not a matinee. Okay, now let's go over and look at our logic over here and see if we can, so I can do the same grid, and then I can look up here and see, well, what is my time valid going to tell me? Is it going to be a true or a false? So let's go here. Show hour less than 16. Sorry, let me start in my first case. I'm going to be Monday at 2 p.m. Is the show hour less than 16? Yes. Is it not a Tuesday? Yes. Okay, so this whole clause, first clause is true, and since it's an or, we don't need to check the second clause. We know this one will be true. Okay, what about Monday at 7 p.m.? Okay, first one. Is the show hour less than 16? No, it's not. So this and is going to be false. So let's look at the second one. Is the show hour greater than or equal to 16? Yes, it is. It's at 7 p.m. And is it a Tuesday? No, it's not. So both of those are false. So we get a false. Checking against what we're supposed to be getting, so far so good. So far our algorithm is doing well. Maybe this is good code. Let's look at our next one. Tuesday at 2 p.m. So is our show less than 16? Yes. Is it not a Tuesday? No, it is a Tuesday, so this one's false. Or is the show greater than 16? No, and it is a Tuesday, but that doesn't matter because it's not in the evening. So this one is false or false too. This one actually gives us a false. Now we're seeing an error. It should be yes. We get a false. Let's check the last box too, just to make sure. Let's check the last box too, just to make sure. So Tuesday, we know it's not a Tuesday, so this will be false. So our first clause won't be true. Our second clause, it is a Tuesday. Is it after 4 p.m.? Yes, it is. So this one's actually right. So all of the boxes are right except for this one. This is the box that we need to fix. So this logic here, we can say there's a bug. and maybe I'll come back in a moment and we'll fix that bug, but we've highlighted for our showtime consideration, we have a bug. Earlier, we did a quick little in our head confirmation that this one looks right, but our second one appears to be buggy. The other thing we've done is we've highlighted the input that it has the bug on. So we can say anyone coming in on Tuesday afternoons should be eligible. That's what the left-hand side says, should be eligible for the discount, but our code says they're not. Okay, so that's one bug. Let's look at our last bit here. Let's look again, age rating. If the movie is rated R, so notice we have if the movie is rated R. So that part we've actually transcribed well, properly so far. It's an if condition here. So we have an if and an else. Okay. If it is rated R, the customer must be 17 years or older or be accompanied by an adult. So our customer must be greater than or equal to 17. Customer must be 17 years or older. Check. But we have an and here, not an or, and be accompanied with an adult. Let's immediately we might be like, that's wrong, right? Immediately our coding might be like, boop, I know what I need to do. Over here it says or, we wrote and, let's just put in the or that's right. And if you're immediately jumping there and you kind of know why, that's great. But what we want to do in this video and in this process is highlight what our brain is doing automatically for us so that when things are not going to be automatically obvious for us, that we can fill it in. And we were doing it over here. We want to reproduce this, which is find out what input would make that code wrong. Okay, let me go back. What input would make this code wrong? Well, wait a second. This is saying that customers that are aged greater than or equal to 17 must be with an adult. So you have to be 17 and have an adult. Well, we know that if you are 17 plus, you don't need the adult. So one input we could consider is 17 plus and no adult. I mean, if you're 17 plus, you are an adult. Otherwise, we could also say, well, what happens if you're like 15 and you have an adult? If you're 15 and you have an adult, you should be allowed in, right? Or be accompanied by an adult. So this condition here, again, we can highlight, there's two different inputs that we might want to try. And those inputs we can show, oh, when it gets to this stage here, age valid is going to be false when it should be true. Okay, it's going to end up being false in some cases when it should be true. Which cases? These two cases here. And again, we've already highlighted, hey, we think we know what we need to do here. We'll change that one to an or. Let's check the else condition here. There's no else condition over in our specs. It just says, if the movie is rated R, here are some extra criteria. What it's not saying, and it's leaving just for us to fill in because it's basically vacuous, it's empty, is in the other case, there are no extra criteria. If the movie is rated PG, everyone's allowed in, no extra criteria. So the else condition here just says do whatever you want. And that's why we're seeing in the code, this is correct, that we're just setting age valid to be true here. In the else condition, saying that we don't need to check your age in this case, so you're automatically allowed in. Okay, so we fixed one of our bugs, but I do think we need to fix one more bug, which is how do we fix our logic up here? All that logic is kind of too messy. It's more messy than we need. So I'm just going to write the new logic down here. It's really what we have up here. Let's just transcribe it properly. Okay, so I'm going to say, let's write this simpler piece of logic instead. If the show hour is less than 16 or it is a Tuesday, then we should be able to, then the time is valid, so we should be able to access our student discount. Okay, if we've corrected those bugs, then we might still think to ourselves, well, how are we sure that there are no bugs? We found some inputs here. We could definitely go and check these inputs again, and that would be one way we can do it. Make sure that they pass on these inputs. But there seem to be a whole bunch of different inputs that we need to test. And in a sense, we kind of feel like we need to test all the inputs to make sure that it works. And often when we have automated testing, we might be testing a lot of different inputs. But the truth is we don't actually have to test every single input. There's infinity of them. Instead, what we're going to need to do is come up with a collection of inputs that are exhaustive. Exhaustive meaning they cover all the cases, all the branches in our logic. Okay, and we need to be able to look at our logic and analyze that logic and come up with what are the different branches that we could have. So I'm going to show you how we can do that right now. So the way we can do this is by looking at we actually had 7 possible inputs here, right? And we can look at each one and we can think about what are the different possible values that these inputs can take. Some of them will have infinite values they could take. So in those cases, we might need to do a little extra reasoning. But this first one has student ID. This is just a true false. So when we're looking at inputs, we should try at least when this is true and also when this is false. If we only try cases when it's true, we haven't tried all the cases, obviously. Okay. And then also we have is enrolled, and we can get true, false for that one as well. It's another Boolean. Now I want to highlight as well, when we scroll up here, those 2 values, having the ID and being currently enrolled, are only used in this first criteria, student status. So there's a sense that these 2 are bundled together, but they are not bundled with the other ones, meaning that we should try all combinations of these 2. So we should have true and true when they're both true, true and false, false and true, and false, like a normal truth table we might build. We should try all 4 of those possibilities, but when we try them, we just plug them into this first piece of logic, and if that logic works out for those 4 cases, we know that this one is done. It's isolated from the other 4 pieces of logic. These 2 variables are not used again. So we've kind of already done that, not for these 2, but for our matinee, not matinee, Tuesday, not Tuesday logic. Let me show how that works here. So our next one's here, our show hour. This is interesting. Our show hour, well, what could it be? Well, I imagine it could be like 0 to 23. That's just a guess. Maybe it's 1 to 24. These are the times of the day, but notice there's 24 different categories here. That doesn't mean we need to try all 24. We can go up and look at our logic here, both in our specs, but also in our math, and see that what matters is 16, the number 16. So really, we can split this into a partition by finding that number 16 in the middle, and we have the ones on the left, we can say greater than 16 true. The ones on the, sorry, I did that wrong. Ones on the right are greater than 16 are true. The ones on the left are less than 16 are false. And now we've turned our show hour into just a true false as well, just like these ones as well. Our Tuesday was already a true false. And that's what we have in our little spec up here. That's what we did. Okay, we said, I'm going to treat my Tuesday as a true false, Tuesday and not Tuesday. I'm going to treat my show hour actually as a different variable. We called it matinee. We said matinee or not matinee, which is just a true false. And then we made, this is kind of like a truth table, but awkwardly drawn as a grid instead. We have our 4 possible combinations of true false here. And we went for each one and tried to see, should we give the student discount or not? And then we went to our code and said, do we give the student discount or not? And that's exactly the kind of test you will be doing in your proof. Okay, if we wanted to prove our code correct, we would go through those 4 cases here, because these 2 are bundled together as well. We go through those 4 cases, and we make sure that our code answers correctly on all 4 of them. Finally, our last 3, our movie rating, wait a second, it's going to be like R or 13 or PG or G. But remember, just like our show hour, we only cared about R. So we're really caring about, is this equal to R or not equal to R? And that produces our true and our false category here. So we end up with just 2 cases again. luckily. Customer age, same thing. It could be 0, 1, all the way up to, I guess, 99 or something like that. But what is it that we care about? It was greater than 17, greater than or equal to 17, technically. Okay. And once again, that can turn it into a true false for us. And once we have it a true false, it's much easier to iterate through all the cases. We don't need to try all the ages less than 17, just one, like 15. We don't need to try all the cases greater than 17, just one, like 25. And then we're good. With adult, that one's naturally a true false. What we see here is we end up with 3 true false categories. When we had 2, we had 4 combinations. When we have 3, we end up with 8 combos. How do I know that? We have all these 4 with the true out front. Each one gets a true. And then we have another 4 where we put a false in front. And then that's our total for our 8. So there's 8 more cases here we have to consider. Going through all of this, if we wanted to prove this, given our math here, the way I would do it is I would make 4 cases for the first one, 4 cases for the second one, 8 cases for the third one, for a total of 16 cases. Oh, that sounds really ugly and messy, right? But they're really simple logic tests, just like we did up here. Each case, I would just look at it, look at my logical statement up above, and just say, yeah, that one's true or that one's false. So this is 16 cases, but it's basically a truth table. And if you wanted to, if you're doing a proof of one of these, one way to organize your proof is to just make a truth table. And you make a truth table of the 16 cases you need to test, and then you highlight that that your code is correct in each of those 16 cases. And then now you've exhaustively proven that your code is correct. Also, we're in discrete math, we're thinking about proofs, but often we're just coders. So what does this really mean? Go into your test and write 16 test cases. If you write the 16 test cases in your test suite, like your JUnits or whatever, and you just press run on that, you know your code works because it will pass every possible test you have. Okay, hope you like this practical reasoning episode again. Stay tuned. We'll see you in that next episode.